Determine all critical numbers for the function f of x equals x times the square root of 2 minus x squared. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x equals x times the square root of 2 minus x squared. X is a polynomial and has a domain of all reals. The square root is an even root. It can be rewritten as the 1/2 power, and the denominator is the root and is an even number. And an even root does not necessarily have a domain of all reals. What's inside of the even root has to stay greater than or equal to 0. So 2 minus x squared has to stay greater than or equal to 0. We can subtract 2 from both sides. So negative x squared has to stay greater than or equal to negative 2. We can divide both sides by a negative 1, which will flip the inequality. So x squared is less than or equal to 2. We can take the square root of both sides. The square root of x squared is the absolute value of x. And the absolute value symbols can be removed by putting x between the negative square root of 2 and the positive square root of 2. This will be the domain. So the domain is negative square root of 2 included, square bracket, all the way up to the positive square root of 2, again included, so square bracket. The next thing to do is find the derivative. F prime of x equals. We have a product rule. The first is x, derivative of x is a 1 times the second left alone, 2 minus x squared to the 1/2 power, plus the first left alone, x, times the derivative of the second, which is a power rule. Bring the power down, leave the inside alone, subtract 1 from the power, I will call it 2/2, and then multiply by the derivative of the inside to complete the chain rule. The first term is 1 times a quantity, and 1 times anything is itself. The second term will collect the constants together. There's a 1/2 and a negative 2. 2 times 1/2 is 2/2 or 1 with the negative. So negative 1 will move to the front. There's an x and there's another x. Multiplying those together will become x squared. And then there's the 2 minus x squared to the 1 minus 2, negative 1/2 power. Since it has a negative power, it will need to move to the denominator and become a positive power. So 2 minus x squared to the 1/2 minus the x squared will stay in the numerator. And the 2 minus x squared will move to the denominator to become a positive 1/2 power. As soon as one or more terms in a derivative end up with a denominator, all terms will have to be put over a common denominator. To find critical numbers, we have to have a single fraction. So we need a common denominator here. The first term has a denominator of a 1. The second term has a denominator of 2 minus x squared to the 1/2. So we will need to multiply the first term by 2 minus x squared to the 1/2 over itself, a form of 1, to give it a common denominator with the second term. The first term has a numerator of these two multiplying each other. We can add the exponents. 1/2 plus 1/2 is 2/2 or 1. And so it will give us 2 minus x squared to the first power. The second fraction has a numerator of minus x squared. We will combine these together over the common denominator, since they are now over a common denominator of 2 minus x squared to the 1/2 power. We can combine like terms together in the numerator. 2 minus x squared minus another x squared is minus 2x squared. In the denominator, 1/2 power can be rewritten as square root. And one more thing, we can factor a 2 out in the numerator. And there is the simplified version of the derivative. We can now set the numerator equal to 0 and the denominator equal to 0 to find critical numbers. Starting with the numerator, which is 2 times 1 minus x squared equals to 0. 1 minus x squared is a difference of squares and factors into a 1 plus x and a 1 minus x. And solving for x from each of these, we end up with x equals -1 and x equals +1. Now working with the denominator, the square root of 2 minus x squared equals 0. We can start by squaring both sides. Square root squared cancels itself out, and we have 2 minus x squared equals 0 squared, which is 0. Subtracting 2 from both sides, dividing both sides by a -1, and then taking the square root of both sides, which will give us a plus or minus square root of 2. I will write these separately, the positive square root of 2 and the negative square root of 2. Now we'll check and see which one of these are in the domain to be critical numbers, starting with the x equals -1. Well, the domain is negative square root of 2 to positive square root of 2. Square root of 2 is greater than 1, because the square root of 1 is 1 and the square root of 4 is 2, and it sits somewhere between. Square root of 2 is about 1.4. So the domain is -1.4 to positive 1.4. Well, -1 is within there, so we keep it. It is a critical number. +1 is in there, we keep it. The positive square root of 2 is one of the endpoints. It's the right endpoint, and it's included because of the square bracket in the domain, so we do keep it. And same thing with the negative square root of 2. It is one of the endpoints. It's the left endpoint. Due to the square bracket, it's included, and we keep it. And there are 4 critical numbers for the function. X equals -1, x equals 1, x equals the positive square root of 2, and x equals the negative square root of 2.